Welcome to Lesson 5 of the Swift Fundamentals with Bob. Since Lesson 1, you've learned a number of question marks and those bangs in Swift. These are the language features that distinguish Swift from the rest, and you got to know when, where, how, and most importantly, you got to know why you use them. In this lesson, you will learn how to convert types of an object that are created with classes and structs. If you use Storyboard in iOS development, you have used typecasting before, so let's find out what goes underneath the hood. Alright guys, welcome to typecasting. In this lesson, we're going to take a look at how do you distinguish between as question mark and as exclamation mark, and also why does Xcode keep telling me what to do. I'm sick of it. And most beginner iOS developers face this problem, right? Why does Xcode keep telling me what to do? In this lesson, we're going to prevent that from happening, okay? So first of all, you have seen something like this in the past. Typecasting in UIKit, all right? UIKit, you have a label, you've created the label object, and sometimes you'd be like, oh, what is UI view right there? But why is this happening, okay? Well, let's try to replicate this feature by using a custom class. What are you doing right now is literally converting UI label to UI view, but I'm going to explain to you by creating our own class. So first of all, I'm going to create a class called human, a simple class called, and contains a method called introduce. And then you want to create this, you also want to create a subclass that inherits the human class. And I'm going to call this Korean, okay? And also contains this beautiful method called sing Gangnam Style, okay? And then print Oppa Gangnam Style, all right? That's a Korean way of saying it. Okay, cool. So if you make an object, we'll call Bob as Korean object. Not only contains an introduce method that inherits from the human object, a human class, but also you have the sing Gangnam Style method that comes from Korean, okay? All good. Oh, good. But now sometimes, let's say, hey, can I convert Bob? Right now, the type of Bob is Korean. Can I convert the type of Bob to human? Is it possible? Yes, you can. So let me tell you how you do it. We call this typecasting. You are able to convert type. For example, you can simply say, let Bob, new Bob equals Bob as human. So if you click on it, now new Bob becomes human. And of course, if you remove the as human part, it's literally just Korean. But of course, if you now do as human, now it becomes human type. But if you know correctly, human type only contains one method, all right? It doesn't contain sing Gangnam Style. Well, let's take a look at it. New Bob and introduce, yeah, it definitely contains that hello, I'm a human on the bottom here. But it does not contain what do you call that? Sing Gangnam Style. It doesn't contain that method. Why is that so? Because you've converted Bob from Korean to human, okay? We call this process upcasting. Here's why. We call this upcasting. Here's why. Well, let's go back to understand what upcasting means. It's important. It's better to take a look at this example. So this is a UIKit. Let me show you the UIKit framework. Don't get overwhelmed. I'm going to take a look at this UI view and the UI label here. UI label is a subclass of UI view. So anything that has UI view, also UI label has it. But here, when you create this object, you are simply creating this UI label here. But what you're doing is you are converting to UI view, okay? You've said you're able to do that because it is a UI label is a subclass of UI view, okay? That's possible. As we've seen it before, just like here with a Korean human relationship. But when you're doing it, what you're doing is you're upcasting. You're going up. You're going up to the letter, going more generic. Yeah, that's called upcasting. You're up converting, and the opposite will be downcasting, right? Coming from UI view to UI label. I'm going to talk about it in a second. Okay, so I hope you guys understand that upcasting is nothing more than converting from specific type to the generic type which you inherit from, okay? That's called upcasting. And when you do upcasting, you use as. It's always gonna work. Why is that so? Because if you think about it, upcasting is getting rid of properties and values and methods. So if you upcast from Korean to human, you are getting rid of the Sing Gangnam Style and any properties that are associated with the Korean class. So if you get rid of something, well, you can always, it's always gonna work, right? So if you get rid of it, then it's gonna work, right? So now Bob as human introduce, it works. I hope that makes sense to you. If you, right, it's always gonna work. Becoming more generic. Hope that, am I making sense? Hopefully I'm making sense. So again, if you use as, means your upcasting is always gonna work. Okay, always gonna work. Let's create a dummy called Japanese as well. Human, Duna Ninja. Shh. All right, doesn't mean much. I'm gonna use it for a later example. Okay, so I'm gonna give you an upcasting example with the Swift language. So upcasting with normal / common types. So for example, you can have a var name. Let's call this Bob, or you can use your own name. And also we have a number 1220 right now. So if you take a look at it right now, the number name is string, and also number is also int. But here you can also convert to a generic type, which is called any. Okay, you guys probably seen it before. You can convert it to any. But here's the magic. But why do we upcast in the first place? Well, the benefit would be you are able to combine seemingly non-related object into one single array. This is what I mean by that. You are able to do something like this. Any array equals name, comma, number. If you were to use without upcasting, you're not allowed to do that. You're not allowed to store string and int in a single array. You're not allowed to do that. So you have to convert upcast to the very top here. Any is something that just exists by default in the Swift programming language. Okay, you're able to combine into something like that. So that's what upcasting is. Hope I'm making sense to you. Okay, so here's a problem. Sometimes you want to downcast it. So what I mean by that is, okay, this array contains name, but now you want to work with it individual level. So what you have to do is you have to downcast it. You want to convert from any to its normal type, which is a string. So downcasting, as I said, is the opposite of upcasting. You're going from UI view to UI label. That's downcasting. Okay, but here's the problem. UI view can technically, you can be image view, could be UI view, UI control could be UI view. However, UI view can also be UI table view, UI image view, UI label view, UI stack view, right? From the bottom to top, it always converges into UI view, but from UI view, it diverges into many sections. So what does that mean? Well, you can say, hey, you don't exactly know whether name, right, is a string or int. You don't exactly know whether number is, because I call it name number, you can kind of tell that this is a string, but sometimes you cannot tell whether this is what value, what type it contains by its DNA. Okay, so sometimes you might fail to recognize, hey, this is string. Is it string or is it int? So downcasting, on the other hand, may fail. Okay, upcasting may work, always works, but downcasting, on the other hand, may fail. Okay, so there are two ways to downcasting. One is a safe way, and one is the forced way. Okay, so this part we covered the as part. As means is used for upcasting, but when it comes to downcasting, we're going to use this too. Okay, so let's try to downcast. Let's try to downcast number and name. So in order to downcast, we all have to do is, I'm just going to copy the titles and subtitles. Downcast. Let's talk about the forced downcasting. So let's get the new value from the any array. Let's get the number. So it'll be 1, right? And the only thing you have to do right now, if you take a look at it, is any, right? But you want to downcast it from any to a specific type, which is you have to use int like that. You're not allowed to do this. This as is only used for upcasting. Right now you're downcasting, so you have to use either exclamation mark or question mark. So what you get is you get this normal type, or a normal type, return normal type. You get this normal type, but here's the problem. All right, sometimes you're not able to guess what the original type might be like. So another value any array. And if you do something like this, right, you're gonna have a lot of error. You're gonna have the problem. Why is that? So because by its DNA, as you know, number by its DNA is string, right? So it is int. And if you try to force typecast to a string, it's not gonna work. That's why, hey, you cannot convert from Swift into Swift string. So force unwrapping will not gonna work. So as you know, you don't want to force anything when it comes to programming. So this is not the best practice. Try not to use forced downcasting because it might fail. So here comes a safer way, which we call it as implicit downcasting. The safer way using just optional way. So what I would do is something like this: new value equals any array. Right now the 0 is name, and by its DNA, it is string. But if you try to do it as an int, well, it's simply gonna return nil. So what does that mean? If you take a look at new value, is optional. So in Swift, as soon as you see this question mark, you are expected to see an optional value. Okay, that's a rule. Okay, that's it. So and of course, when you get the right int type, so right now any array right now is number, right? If you try to downcast it with a question mark int, yes, it's gonna work. But the only problem is that you're gonna get an optional type, which is int question mark. So you have to unwrap it either using if let or just like something like that if you wanted to. Okay, but of course in real practice we're gonna use the safer way of using it. So far we talked about it. Why do we even downcast and upcast? You might have that question right now. Well, don't you worry. I'm gonna walk you through why this might be useful, but it's not the best practice. But we can also learn a lot from this lesson. Well, let's talk about this. What I'm gonna do is what upcasting allows you to do is, as you're sitting here, it allows you to group objects that are similarly different and they don't share the type together into a single array or dictionary or sets. So I'm gonna show you an example. So I've created a couple people names, Japanese, Korean. That's Park is my mom's last name. Lee is my last name. All right. So they're different in types. All right. They're Japanese type, Korean type, Japanese type, Korean type. However, they all share the fundamental root. What's the fundamental root? If you go back here, they actually all come from human. Okay. And here's a magic happening. You are able to do something like this, like that. Humans, Shion as human, Lee as human, Kenji as human, Park as human. Okay. And also specify that this is a human type. But in fact, Swift is smart enough that as long as you share the same parents, you are able to do something like this. Shion, Lee, Kenji, Park. Because Shion comes from human, Lee comes from Kenji, they automatically upcast it for you. So if you now take a look at option, click on it, let Shion Japanese, but at the end, it all converges to human type. So if you don't believe, let's take a look at it. Human dot, let's get 0, and it should contain that introduce function. It doesn't really have that. It doesn't have what do you call that? Do ninja function. It doesn't have it, right? The only function it has is a human. What's associated with human, which is introduced. Okay. So why is this useful? Well, we're gonna take a look at this. We can do something like that. We can use for and lib. You can say for human in humans, okay, and you can say if let Korean. Let's create a constant of Korean and human as Korean. If it's Korean, then you can say Korean dot sing. Where is that? Sing Gangnam Style right there. And if the human right now is Japanese equals human as safely unwrap Japanese. You can say Japanese dot do ninja. So what's happening is you were able to group them together. Now you're able to run their own distinct function method associated with human and Japanese, just like that. Magical. You're able to group them together, and then voila, that's them right there. Okay. Well, without practical example, this is not enough. I'm gonna give you a practical example in iOS development how this can be useful. So practical typecasting. So let's say we have a couple buttons and messages, a view that are available in your view controller or your storyboard in your lab, button label view. But if you think about it, as I said, they all share the same fundamental parents, which is what UI view here, right? Button, where's the button? UI button comes from UI view as well, even though they come from UI control. Control comes from UI view, UI label, and also UI view is just UI view. So what you're allowed to do is you are able to do something like this. UI components, a UI login view, login message, they all convergence into UI view right there. And you don't have to specify this is UI view. You don't have to do that. Swift is smart, again, just like what we've seen here. Swift is smart enough to recognize that, hey, they all share the fundamental parents. Let's try to combine them together by upcasting automatically for us, okay? Well, here's a magic. Similar to what we did here, you're able to group them together, right? Very handy, very portable, right? And you're able to apply some sort of a setting or some sort of changes to each object by downcasting. So this, I'm gonna give you one more example like this. I'm just gonna copy paste because this is not that complicated. So let's say for component in UI components, okay, components, and you have an object, and you're gonna do something like this. If let button component as UI button, right? This normal type, and you can change the background color, add title, whatever you want to, okay? That's and also for label, you can change the background color of the label, you can change the font size of label, UI label and view, and do whatever you want to, okay? So when it comes to programming, when it comes to iOS development, you are able to group this UI object into one single basket, into one single array. You're easy to carry around, and then if you need to by upcasting, and also if you want to apply specific logic, specific attributes to each object, all you have to just go through the loop and then be able to use this if let downcasting to do what you want to do. Okay, that's a handy feature, but downcasting, upcasting is not the most practical way in iOS development. There's a better way called protocol-oriented programming. You're gonna learn a lot more in later chapters, so you guys should be very, very excited about this. Okay, so and lastly, you guys have seen something like this UI, and also you guys, if you never used that typecasting before, this is wrong. You've been using typecasting a lot in your programming. For example, you have something like UI storyboard and you have a main, right? If you've never done programming in iOS development, well, this can be confusing, right? You have a storyboard and main here, and then you might have done something like this. Let VC storyboard instantiate view controller with identifier VC. But the problem is, if you take a look at VC, it's the UI controller. It is a parent of UI view controller. So sometimes you have to downcast it to VC in order to have the methods and properties that you want it to have. All right. So VC is let's say this is your custom view controller that inherits from UI view controller. Without using this, the VC is going to be just simply UI view controller. It's not your custom UI view controller that inherits from UI view controller. Okay, so that's why you use as okay, that as thing right there. Okay, hope that makes sense to you. Boom. Most people think typecasting applies to classes only, that you can go from the superclass and lower class, but that's not the only case. We also learned that structs also provide typecasting. For example, string value and int value, you make typecasting to any. However, unnecessary typecasting is not recommended among iOS developers. If you start using typecasting back and forth, what happens is you have to use those as keywords as well as if let. Code becomes much longer than necessary. So if you want to learn how to group things together, well, in chapter 3 you will learn how to combine a multiple object using protocol-oriented programming. I know you're very excited about that. Well, you'll get there eventually, and I'll see you soon. In the next lesson, you will learn how to create reusable as well as scalable code base by learning about generics. You will come out dry, not wet, also known as we enjoy typing.